cathode is defined differently depending on the context. Firstly, in an electrochemical cell, the cathode is the electrode where reduction occurs, meaning it is the electrode where electrons are gained. Secondly, in an electron tube or a semiconductor device, the cathode is the electrode from which electrons leave. Thirdly, in a vacuum tube, the cathode is the negative terminal. The anode is also defined differently depending on the context. Firstly, in an electrochemical cell, the anode is the electrode where oxidation occurs, meaning it is the electrode where electrons are lost. Secondly, in an electron tube or a semiconductor device, the anode is the electrode to which electrons flow. Thirdly, in a vacuum tube, the anode is the positive terminal. In the context of the high-pressure mercury lamp, these definitions help to understand how the arc is sustained. The alternating current supply causes the electrodes to exchange functions as the polarity changes. During one half cycle, one electrode acts as the cathode, emitting electrons, while the other acts as the anode, receiving electrons. In the next half cycle, their roles reverse. This switching ensures a continuous arc discharge as long as the mercury is vaporized. The electrochemical cells involve chemical reactions that produce electricity, or use electricity to drive chemical reactions. Reduction is the process where a species gains electrons, decreasing its oxidation state. Oxidation is the process where a species loses electrons, increasing its oxidation state. The cathode is the site of reduction, and the anode is the site of oxidation. Electron tubes, including vacuum tubes, are devices that control the flow of electrons in a vacuum or a gas-filled space. These tubes utilize electrodes, including the cathode and anode, to manipulate electron flow for amplification, switching, or rectification purposes. The cathode in an electron tube emits electrons typically through thermonic emission, where heat is used to liberate electrons from the material. The anode, also known as the plate, attracts these electrons, creating a current through the tube. Semiconductor devices, such as transistors and diodes, rely on the properties of semiconductor materials to control electron flow. These devices also have electrodes analogous to the cathode and anode. For example, in a transistor, the emitter can be considered the electron source, similar to the cathode, while the collector acts as the electron drain, similar to the anode. The behavior of these electrodes is governed by the doping and biasing of the semiconductor material. Vacuum tubes are a specific type of electron tube where the electron flow occurs in a vacuum. The absence of gas molecules allows electrons to travel unimpeded from the cathode to the anode. The cathode in a vacuum tube is typically heated to emit electrons, and the anode is positively charged to attract them. The flow of electrons can be controlled by applying voltages to other electrodes within the tube, such as the grid. The high-pressure mercury lamp operates on the principle of arc discharge to mercury vapor. The arc tube contains argon gas to facilitate initial starting. Once the arc is established, the mercury vaporizes, becoming the primary conducting medium. The electrodes alternate between being the cathode and anode as the alternating current changes polarity. This alternating role is crucial for maintaining the continuous light output of the lamp.